Hey everybody, these are the 2D non-metric conversions notes you'll find on page 11. So you can copy these down as I walk you through these three problems. So in this first problem, we're trying to convert from 16.5 decimeters into inches. We're going to need to go to the back of your periodic table, this section on the back of the periodic table called equalities, and I want you to look at the following equalities. First of all, in the problem, it talks about decimeters, so we're going to need to eventually write this down. The decimeter is 1 times 10 to the negative first meters. And then we need some kind of equality that has inches in it, and there's one up here. 1 inch equals 2.54 centimeters. Now that centimeters means that that's our jump from metrics to inches. So we're going to have to look down here at what a centimeter is in terms of meters as well. So we're going to need to know that a centimeter is 10 to the negative 2 meters. So I'm going to write all these down. Here's what we know. We know that an inch, 1 inch, is the same thing as 2.54 centimeters. We know that a centimeter is the same thing as 10 to the negative 2 meters, and we know that a decimeter is the same thing as 10 to the negative first meters. Now we just have to put everything together. So I'm going to start the problem with 16.5 decimeters, 16.5 decimeters, and now I need to pick the equality that's going to allow me to cancel out decimeters. So this first equality right here is going to take me from decimeters to meters, and that's what I'm going to write down next. I'm putting the decimeters on the bottom so that they cancel. Now my next objective is to get from meters to something else. So I'm going to go from meters to centimeters next. I forgot to write that unit up there. So I know that 10 to the negative 2 meters is the same thing as a centimeter. And finally, I want to get rid of those centimeters, so I'll go from centimeters to inches with this last equality. I know that there's 2.54 centimeters in 1 inch. And just to confirm I did this right, I'm going to make sure that my units divide out. So decimeters are going to divide out, meters are going to divide out, centimeters are going to divide out, and I'm good. To do the math here, I want to take 16.5 times 10 to the negative first divided by 1 times 1 divided by 10 to the negative 2 times 1 divided by 2.54. And when you do that, you should get on your calculator 65.0 inches. And that's the answer. In this next example, I have to convert from 14 days into seconds. So basically, I'm going to take a day and I'm going to break it down unit by unit until I get into smaller units of seconds. So I know, for example, that 1 day is the equivalent of 24 hours. And I know that in 1 hour, there are 60 minutes. And I know that in 1 minute, there are 60 seconds. So now I just have to put this all together, and starting with 14 days, I'm going to use these three equalities to eventually get to seconds. So I start with 14 days, and I'm going to use this first equality to get from days to hours. I know that 1 day is the equivalent of 24 hours. Now I use the second quality to get from hours to minutes. So I know 1 hour is the same thing as 60 minutes. And finally, I'm going to go from minutes to seconds. So I know that 1 minute is the equivalent of 60 seconds. So again, to do the math, I'm going to take 14 days, I'm going to multiply by 24, divide by 1. Multiply by 60, divide by 1. Multiply by 60 again, divide by 1. And your final answer is going to be huge. So it'll be 1.2 times 10 to the 6th seconds. And that's just rounded. It's a lot of seconds. Okay, this last problem is a little bit more complicated because here we've got we have units in both the numerator and the denominator that we have to cancel. So we're actually starting with a ratio. It's not really hard, it's just that you have to worry about the numerator and the denominator kind of at the same time. So here we're going to have to convert kilometers into miles, and then we have to convert hours into seconds. So I'm just going to write down everything that we know. If you look at the back of the periodic table in that equality section, you'll see that there's an equality that says for every 8.0 kilometers, that's the equivalent of 5 miles. So that gets me the relationship between those two things. And we already know that an hour is the same thing as 60 minutes. And we know that 1 minute is the same thing as 60 seconds. So that'll give us enough to solve this problem. When you start the problem, and this is super important, do you see where it says km/hour? What you should do is you should write down this number like this: 2.88 times 10 to the 4th, and write the kilometers, but put it over 1 hour, like that. Don't write it as a slash, but just write it as a regular whole division sign. Now, just focus for a minute on the kilometers. So you know, based on this equality, that 8 kilometers is 5 miles. So I'll write that next. 8.0 kilometers is the equivalent of 5 miles. That's great. We got rid of kilometers. Now, we're just going to focus on the hours. So we know that an hour is 60 minutes. But this time, you want to cancel out the hours by putting the hours on top of this fraction so that they will cancel that way. Finally, we want to get from minutes to seconds, so we'll use this last equality. And again, the units have to be of minutes have to be catty corners, so I'll put 1 minute at the top is 60 seconds. Sorry, that's supposed to say 60 seconds. There we go. Okay, so the minutes are going to cancel. So now we are left with these units of miles and seconds, which is exactly what we want. So when you're finally calculating this, you are going to take 2.88 E4 times 5 divided by 8 times 1 divided by 60 times 1 divided by 60, and you should end up with an answer of 5 miles per second. And that's it. So what I want you to do is I want you to try the problems on page 16. And the top of the page says non-metric conversions worksheet. It actually says extra practice, but I want you to try them. If you get really stuck, at the very least, see if you can come up with a list of equalities to use in the problem, and then we'll work on them some more next week. Good luck.